So one-sided limits. We've done these. We did these in the pictures. There was a couple of those on the warm-ups. The little minus sign means from the left. The plus sign means from the right. So we're at least familiar with what they look like and maybe kind of how they work. The new thing for today is one-sided limits from equations, as opposed to from a picture. When you get the hang of it, pictures aren't really that hard. You understand what they're asking. You just look at the picture and get the answer. If we give you an equation, it's usually a little bit harder to do it from an equation. There's two All right, what do we think? If x approaches 2 from the right, any guesses what the limit would be? 0. Everybody okay with that? Anybody not okay with that? Want some explanation on that? How about as x approaches 2 from the left?
Does not exist.
Why doesn't it exist?
Because of the negative number.
Yeah, you're trying to take the square root of a negative number. You're at almost 0 on both of them, but one of them is a positive almost 0. You can square root that. One of them is a negative almost 0. You can't square root that. If we had done this graph from the get-go, think about parent functions here. That's what we're doing in pre-cal right now. What's that minus 2 do to the graph? But it's minus 2 in there with x. But the left-right thing is backwards. Man, it's been a long time. So it goes right 2. So roughly speaking, there's what the graph looks like. And so maybe if we'd have done that first, x approaches 2 from the right. So the right-hand side of 0, or 2, we're headed to 0. On the left-hand side of 2, there's nothing there. So again, I'm trying to match up substitution and graphically, and they give you the same thing. Just depends on the problem if you can handle graphical or substitution. You got to put in almost 2. Because, well, you can put in 2 first, but then when you get 0, you should be thinking, wait a minute, something may be going on here. Because it does take a little bit of knowledge of the graph that, like, at 2, something weird is happening. So I better check on both sides. Because you're right, if all you did was straight substitute 2, you'd get 0, but that's not exactly right. So you have to have a little bit of knowledge of what the graph looks like so that you can be cautious when the weird stuff is happening. Speaking of weird stuff happening, do you remember what that function is? I don't know if we did that in pre-cal, or if we did, it was during the virtual days, because we're doing it right now, but that's a long time ago for you guys. It's called the step function. When you see what it looks like, you'll understand why it's called a step function and why there are lots of limit questions with the step function. Makes stair steps. It's also the round down function. That's not ever really what it's called, but that might help you know what to do with that thing. So the step function of 2.2 rounds down to 2. The step function of 2.99 rounds down to 2. So it's not rounding like with the usual rules of rounding. It's go down to the biggest integer to the left. So the limit as x approaches 1 from the right, and you could look at the picture, or you could kind of do a table even. So that means I'd be plugging in things that are a little bigger than 1. Well, I guess let's do it 2 different ways. Let's look at the picture first. So if I'm approaching x equals 1 from the right, can you tell from the picture what that limit will be? It'll be 1. If I'm approaching from the right, it'll be 1. a way to check that would be to plug in things that are a little bit bigger than 1. So 1.01, 1.00001. All of those equal 1. Like you just round down to 1. But the limit as x approaches 1 from the left, so as x approaches 1 but a little bit less than 1, what's that answer? 0. Because then you'd be plugging in 0.99, which rounds down to 0, or even 0.999999999, but that would still go to 0. So the limit from the left, either from the picture or from the substitution, is 0. Which means, if I don't specify left or right, if from the left was 1 and from the right was 0, what's the overall limit as x approaches 1? Does not exist, because they got to be the same thing. Or you look at the picture and you're like, well, from this side it's down here and from this side it's up here. It doesn't exist. How about the limit as x approaches 0 of 1 over x? You tell me, do we want to think about that graphically or with substitution? Because we can do either one. Graphically, I agree, because if you know what the picture looks like, it's a lot easier to do it graphically. And that's one of our parent functions. So hopefully your brain is thinking, I know what that looks like. And it doesn't even have to be perfect. So in your head, or even on your paper, draw a little picture of it. And now, what's the limit as x approaches 0? Does not exist. Yes. Why not? There's actually two answers to why this one doesn't exist. One of them is it goes to infinity, so that would be okay. You could say that. It never goes to a point at any point. You could also say different left and right, because one's going to positive infinity, one's going to negative infinity. So either of those answers would be okay, because the left and right have different limits, but they're both infinity, so that one just blows up.
Okay, when we have when does not exist, you have to say why
Yes.
on the place.
I don't remember. I don't have it up here. Sometimes we ask for it, sometimes we don't. So I just keep saying why in case we do ask for it. If you did do it substitution-wise, you'd be putting in things like 0.00001. What's 1 divided by something really, 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 really small? Something really, really, really big. So it's headed toward infinity, so it would be d and e. So if you didn't know what the picture looked like, you could still plug in numbers. And if you plugged in negative 0.001, you'd get negative infinity. So again, either way, it works or doesn't work for the same reasons. Last one, limit as x approaches 1 from the right of f of x, where f of x is this piecewise function. Just because piecewise, for some reason, really messes people up. So f of x equals x when x is less than or equal to 1. F of x equals 1 minus x when x is greater than 1. I really don't want to do this one graphically because I don't want to have to graph that piecewise. So I think I just want to plug in things that are a little bit bigger than 1. I'm going to use the substitution method. So if I'm going to plug in 1.00001, which branch of the function is that going to go into? The A branch or the B branch? Which one? B, because we're bigger than 1. In fact, if we're coming at 1 from the right, the A branch is never even going to matter in this problem. I could have put anything there and it wouldn't matter, because coming from the right, we're always bigger than 1. The B branch doesn't get to 1, but that's okay. Limits don't get there. They just get really close to it. So we plug that into the B branch and we get 1 minus 1.00001. I mean, I could write 0.00001, and I guess I should. And you could do that a couple of times, but eventually I think you'd figure out what's the limit approaching, what's the answer getting closer to? 0. From the right. From the left, what would I have to plug it into? Which branch would I use? A, I'd use this branch and plug into there, and I guess if I plugged in 1, I'd just get 1. So this picture must have a jump at x equals 1, because the limit from the right is 0, the limit from the left would be 1. So use your piecewise stuff to plug it into the right spot. Alright, the assignment's page 79. 1 through 25 odd, but you can skip number 15. Oops. You can see it. And again, what's due on Wednesday is the worksheet on the beautiful function, page 55, and then there were 2 page 67 assignments. So page 79 is not due tomorrow, because I want you to have a day to try it on your own, a day for us to talk about it, a day for you to kind of process it, rather than just racing through and copying answers. That's not the purpose of homework. So those 4 things are due tomorrow, and then of course we have a quiz tomorrow as well.